Chapter 18, Mastering Solidworks. Using the Hole Wizard. Hole Wizard, you have the toolbox database for the channel has hole types inside of the toolbox. Even the cover in this box, we cover the describe of the Solidworks standard. Toolbox is hardware configuration most experience. You do not use the intended method. Toolbox implementation, if done correctly, can cause problems when sharing data, especially when you're upgrading with the version of SolidWorks installation. Whole Wizard is mainly used in part, but it can be used in assemblies. It makes sense to use the Whole Wizard assembly to make sure the holes between the parts are properly aligned and parametrically linked. Smart fasteners work with the Whole Wizard. Automatically fills the holes created with a wizard with the hardware. The whole series is another assembly based on the automated tool with the link of the counter board clearance and the threaded holes in the different parts of the fasten stack. So over here it shows the smart fastener. The Hole Wizard enables you to place, wizard stick on the hole. Hole Wizard enables you to place hole with many types of the screw for the normal loop for the closed fit. With the Hole Wizard created the holes assembly feature. The assembly as a feature, individual part for the rebuild with the context of the assembly with a series hole with the link channel with the tool is called the Wizard. Because the good you through the process step by step. The summary of the process of using the Hole Wizard to create the hole as follows. Pre-select the face start with the holes. With the initiative of the Hole Wizard commands enables you to eliminate possibility of getting a 3D sketch with the whole center sketch. If you want a hole start for the different planes, you need 3D sketch. Select the 3D sketch button in step 9. Select the type of the hole. Example the counter board, countersunk drill hole, tape with the pipe tap, the legacy. If you have the favorite setup, you can select the appropriate favorite and skip the step 9. Step with the standard with the touch of the ANSI inches and metric and ISO standards. The standards. So for the type of screw, for example, the counter board hole, the common with the socket head with the cap screw with the head screws, among others. Select the size of the screw, select the fit of the screw and into the hole, so the normal loose or close. Select the end of the condition of the holes. 8. Select the option clearance of the countersink edge break. Alternatively, you can use the assign with the favorites of the hole setting that you use frequently to want to save, but we'll discuss later in the chapter. Use the customized sizing you need the hole when on standard dimensions. 9. Switch position tab. If you pre-selected the face, you will get the 2D sketch. If the 3D sketch is both is visible, you will also have the 2D sketch. Click with the 3D sketch button. You will be placing the sketch points in 3D sketch. Either case of the point step and place sketch points of the center each hole that you want to create. If you want holes on multiple levels of holes on non-planar surface, use the 3D sketch. Otherwise, use the 2D sketch is simpler and faster. Click OK to accept the type of the placement with a hole. Figure 18-17 shows Hole Wizard Property Manager interface, holes, and then show the type and the position. And then favorites, hole type, standard ANSI, hole specification, size fit, and condition options, feature scope, hole position. Using whole series. Whole series enables you to make sure the context feature for the individual parts for the connected the whole series assembly level of feature and with the check of the parts. For the example, the top of the part counter board with the middle part with the clearance through the hole, and the final part blinding through the thread of the hole. Whole series interface. The whole series of 4 step of the wizard base feature for the inlet of the toolbox is added in turn, which gives the first step process. The first step of the tab of the toolbox involved with the populating with a new hole with a particularly linked with the aster with the small fasteners. Function in figure 818 shows the interface of various steps. 818 shows your fastener series. Hole surface interface. Hole positions, message, hole position, create a new hole, use existing, hole series, start hole specification standards, hole series, middle part, and so we're now in the middle part, the middle of the hole, you can auto size based on the side, screw size fit. And then hole series last part, end hole specification also, start holes, type size, end condition, thread, wood thread called out. Basic whole series steps. When you the whole series with the feature, you must follow the basic step to have the assembly option open. View more parts of the main DVD fasten together the initiate of the whole series of the tool by choosing the insert of the assembly feature holes and the whole series available the toolbar button, but isn't on the toolbar default. The whole series is started from the existing hole, selecting the whole position panel. If not using sketch point, construction, geometry, dimension, sketch relation, locate the whole center applies. Use the center tabs at the top of the property manager advance the one panel with the next start hole specification refers to the part when the series of the hole starts. Middle hole refers to all the parts for the first part and the last part. End hole specification last part is either through the clearance hole or a thread hole. The feature of the feature leave the in context feature of the part each part of the whole series part. Assembly shown figure 1819 and finish hold series. Alright, then you see the welded beads and these T square T joint T joints. Beads are covered in Chapter 36, creating weldments and weldment drawings. But the assembly feature of the welded beads are covered here from slightly different perspective. Although SolidWorks helps refer fillet weld bead feature, there's an actual difference between fillet bead tool and weld bead tool. The icon's similar, but one with a bigger weld with the fillet bead. Um, the icon are similar, but the one with the bigger weld is the fillet weld. Both can be found on the Weldman toolbar, but only the weld bead can be found in the assembly feature menu of the flyout toolbar. Comparing the functionality of the welded bead and fillet bead features, even in SolidWorks helps you with the fillet bead recommends using a welded bead tool instead of a fillet bead to insert welded beads. The weld bead feature offset with some of the advantages over the fillet bead feature. Same interface is available. The part assembly has minimal effect on the performance. Even large number of the welded beads, a basic weld cylinder is created and applied automatically. It works the welded gap, smart weld selection, the tool speed of the selection significantly. Welded properties serve to evaluate mass, production time, and cost. Welded information can be pulled onto the drawing. To be clear, with the fillet bead feature, there's only a welded parts to create the body with additional volume. Welded bead is featured the weldment granule assembly. Creates a cosmetic display body, but not something that affects mass property. The workflow to create welded bead is follows. Select the weld path. The weld path can be the set of edges that may be two bodies of the parts. The set of faces that must be the adjacent parts. Select the multiple weld path paths do not touch. You can select multiple weld paths and paths that don't show. Weld paths appear with a bright pink, the active path, orange existing path listed in the property manager. Smart weld selection tool creates a new weld path automatically based on your selection. Greatly simplified face edge selection. Welded bead creation. Just roughly sketch with the pencil where you want the weld to go. SolidWorks will automatically select the face edge to make the weld happen. To set the size of the weld, draw the weld symbol that includes all the details about the weld for the welder on the drawing. Set the length of the limit on the weld, establish requirements for the intermittent weld for the options given the property to be over the weld bead may be multiple body parts shown in figure 1820. Notice that the welds are organized in size type of the weld. The folder of the fillet weld is the default weld type, the specific another type weld type if it does not specify another type. Property manager looks for the same in the weld done with a multi-body part does, and some of the results all look the same aside with the duplication names. None of this anything to do with the fillet bead feature available on the welded parts. To edit the welded bead, you must be right-click welded bead item listed under the size of the fillet weld in the weld folder. This brings you the original weld bead property manager. So now we've looked at the weld bead, creating a weld bead, weld path, weld selection, weld geometry. Phase 1, phase 2, radius, tangent propagation selection, both sides along, define welding symbol. From to length, intermittent weld. You can manage all other weld properties by clicking size of the weld, selecting the property option. Weld bead properties dialog box appears as shown in figure 1821. 18 and 21 show the weld bead property dialog box enables you to set the following. We have the fillet weld material process, weld per mass per unit length, weld cost per unit mass, weld time per unit length, number of the welded passes. Evaluate some of the number of the welds, total weld length, total weld pass mass, total welding cost, total welding time. Working with envelopes. Envelopes in SolidWorks are regular parts or subassembly that use the selection for the reference to the display only item. They are display only items. You make a selection based on whether the other parts are inside, outside, crossing the envelope boundary. Make an envelope in the place assembly, or you can make an envelope with existing part. Envelope parts does not count towards bill of material part counts and material properties. Certain envelope, you must first insert a regular part. This designates an envelope. Designates it as an envelope. Two places to do this are insert component property manager in the component property dialog box, shown in figure 1821. So we went to insert and then show the part going out of the folder. Message, part assembly, insert, thumbnail options, and then over here common properties. Component name, instant ID, full name, component reference pool, component model, document path, display, site, specific properties, high component reference display, change display, configuration, specific reference configuration, suppression state, solve as, envelope with bill of material change properties. Once the assembly envelope displayed with a graphic window with transparent light blue with the assembled feature manner of envelope fold with the two option envelope function was meant with the work in selecting using envelope, showing how to use the envelope is shown figure 1823, asking these options. Right-clicking envelope feature manager for the graphic windows, then select the envelope. The component selection will also include the volume select. Function enables you to create a rectangular volume of fly, which works for like an envelope. Envelopes can be external virtual components. Envelopes can be shown with a drawing view from the view property interface. They show up with phantom lines, but by default, although they are easy ways to show phantom on the drawing, simply use the component line font tool. Figure 1823 using envelopes. We now have an envelope. You can see the right menu, the menu to that. Understanding smart components. Smart components can compromise several elements, single part with the assembly that may use as configuration. For configuration library feature use illustrated with the mounting holes opening with the smart component associated to hardware. Might be also driven the size configuration training assembly that may be defined with the smart component. As you might expect, some of the more limitations exist. Smart component part cannot have reference with the external with the smart component with a group which is the member to play for the assembly associated library feature can affect only with the component. Associated library feature is limited with these feature types. Accrue with the resolve cut and browse the whole wizard whole simple whole features. The smart setup time of the smart components can be significant. First one or two that the create with especially for the auto side of the option plus for the setup demands of the normal configuration configure parts for the use of the auto side of the function table the most time of the setup because it requires matching configuration auto side of the tab will be well managed, especially with the multiple parts. Still, if you end up placing a given part associated feature of the components made the times manually, but if there's other in your group, the technique that can you save. You learn a lot, team lots. Smart components show the part with a lightning bolt on it. Smart component library part sets up the part needed to make the feature, and another part of the smart component brings these features when placed in the assembly. You can select to make the smart component command tool menu in the tool menu or in the toolbars with the assembly tool, though it may not be on the assembly toolbar by default. 1824 shows a simple assembly took approximately 20 minutes to mount all of the parts and you've set up with the smart component, test it, and assembly. Assembly does not use auto sizing, but it does use the library part and context feature. 2 instance single hardware private piece for the example, an excellent example of the smart component functionality because of the fast agree and implies and save the times whenever you use it. So there's the simple smart component. Getting started with simple smart component. The assembly first play with the electrical connector part with the assemble the mate and play with the assembly smart apply the smart component. When applying smart components, clicking on the smart component with the icons appear with the parts of the graphic windows. When you select with the Solidworks prompt with the select the inside outside face of the sheet metal part. Hardware reference outside with the cutout with the reference for the inside. Solidworks then create with the cutout with the in context feature of the play for the sheet metal part. When creating a smart component with a new folder, the E of the feature menu of the component with the folder containing the required information about the other elements such as the in context feature, any of the other parts of the smart component training the assembly location range reference of locate everything in the left image of the figure 1825 show with the folder connector part, and it's used an example. The right image shows the assembled added assembly feature manager with adding the smart component. The only thing that existed with the design tree shown figure 825 before the smart component was the test box sheet metal part. Feature tree smart component. Feature tree assembly with the smart component has been assembled. Thunderbolt appears on the part symbol at the top of the feature menu. Indicating the part is a smart component. You can play with the smart component in the following these steps. Creating an assembly of the target part of 2 of the target part is one of the smart components will be made with one will have the in context cut out and inserted into the in this case the target point part is in the sheet metal box. Caution, good idea to save the assembly before they add the smart component 2 with the smart component placed before the assembly. Save the assembly with a tendency to forget. Hasn't been saved with the bumps in the context feature for the out context for the name, the change for whatever the default name is assembly 1 solid works assembly S for the name they sign it. Put the smart component into the assembly. You could do this the same way if you add with any of the normal part, including one of the for the design library. If you part with it frequently enough to make with a smart component, if you want to, with the design library for quick access info act, you can add smart component to an assembly without using any of the smart component options. Make the smart component in the assembly. In this case, it is done face-to-face coincident mating in the pair of the distant mates. Apply the smart components. Clicking the smart component symbol over the part, selecting the part with the feature manager. Make small lightning bolt appear with the part that's shown with the figure H26. Alternatively, select the insert smart features on the right mouse button. If you insert many instance smart component, each of the instances will have the option to apply the smart component features associated components. Smart component symbol on the part. At this point, with the interface similar with the library features interface appears with a small prompt window box selecting references shown figure 827. So you have your smart box feature, smart feature, additional smart components, features, cut, extrude, preview components, references, options is selecting references. Click green checkmark icon. Place the smart component with the smart feature within context feature. The associated hardware components with completed the job. You will rotate the part with a small preview window to get a better look at the part. Auto sizing smart components. Auto sizing capability with a smart component with the automatically select the size from a lift configuration based on the size of the geometry on which the being dropped. At a time, the only shift that can be auto size with a cylindrical shape that features figure 28 show the effect of the auto size with the notice of two shaft holders, 2 ends for the same part with the different size configuration. When dragging the size smart component over the small end of the shaft of the configuration comes to correspond with the shaft size appears. As you drag parts along the shaft diameter, increase the next large smart with the component configuration appears. This is part of functional smart components. Each of the configuration smart component is set up to fit with the range of shaft geometries if the diameter on the shaft outside of the range between the side of the smart component is not applied. Sizes are governed by configuration tables, which allow look for similar design table, but was some of the different with the configuration table relate with the configuration smart component configuration of the individual parts, which may also change with the size of the smart component. Serve a subset function of the design table assembly, assigning part configuration, assembly configuration. Figure 829 show the sample configuration table made for the assembly and figure show 828. H29 shows the configuration table. When looking at this table, you begin to understand that creating the auto side of the smart components is much more involved than the first example of the chapter. The configuration smart component are listed in the left. You can select with the individual part configuration each of the cells from the drop-down list of the available configuration for the part, but there's no way to assess that the configuration multiple components at once, nor is there a copy and paste function. The shortcomings combined to make the format less user-friendly for them than an Excel-based design table. Most notable minimum diameter, maximum diameter columns to the right. The columns supplied with the parameters to make the auto side functions work. Solidworks understand the mating side are not exactly equal ability to give the range rather than exact values. Minimum, maximum diameter columns accommodate limitation very nicely, even though the T is set up. Another aspect of set up to show that here with the toolbox part. If you want to use the auto size function, then you need to be using configuration toolbox parts. You should pre-build all needed configurations to show that they are always available. Auto size capability with the creation configuration table is triggered with the auto size panel. Smart component property manager. Exit property manager. Click with the make smart with the component icon. Assembly combine manager. Using tools menu, then open assembly document to edit the small component file with these steps. Open a small component in the open window. Right click with the smart features. Select editing define assembly option. For the upper graphic windows, there will be a small box with the button editing definition. Click edit definition. This will bring Smart Component Property Manager from which you can access the configuration table of other defined features. Making smart components. Most important point is remembering smart components setup. If you need to do it only once for each smart component. The second most important point of the first setup is the most difficult after the subsequent setup. Becomes much easier and create that after the component with a smart component is at the time consuming unless the additional components are also configured auto size. Smart components must contain at least one associated component. One in context feature for the configuration table. The build must be filled without functionality. Trying to create a smart component from a standalone part, nothing happens. The smart component interface is simply closed with because there's nothing to do. Make combine all three elements associated component in context feature auto size. You must have at least one element. Alright, getting started with the simple smart components. Because of the electrical connector shown figure 1827, the ones are the demonstrate with the insertion smart component with the demonstrate with how to create one. All you need to make it a smart component associated smart feature. In this case, the cutout mounting hole with the mounting hardware. In this case, the two standoff screws is the actual part of this part can be imported as a smart component made from the dumb geometry. For example, the you've filled in the file named Chapter 18 connector starting solid part from the Chapter 18 folder. There's nothing special about this part of the model. The Solidworks you've made using standard feature for the nose configuration, special feature for the good have of the download of 3D content. Central of the representative electrical connector that may be mounted with a sheet metal with electrical enclosure. First step, setting up the created mock assembly with the dummy part of the representative sheet metal block with the part does not need to place even in sheet metal for that matter. It just needs to be complete with a thickness that you would be expect with the smart component to be mounted. Assembly is called training assembly, not because you're learning how to make the smart component, but because you're training smart component to be smart. Open the part in Chapter 18's connector solid part from the materials downloaded Wiley website. Make simple rectangular approximately 4 inches square, other 6/100 of an inch thick of the shape of the part with a hard drive. Give the name of the part clear. Belongs to train assembly plug. Replace a rectangular dummy with a new assembly with a new both unique and identifiable. Put the connector into the assembly, make the part over the flange and flush with a rectangular piece also distant made to locate with the connector plane with the edge of the part, similar to figure 1830 in the image to the left. Alright, edit the summary part in context of the part with the assembly, select with the edit part with the offset with the edge of the connector with the part with the extrude cut is shown figure image with the right click on the figure 1830 offset with the two mounting hole with the areas around where the connector stick with the sheet metal about 200th of an inch. Exit the edit component mode of the 2 inch of the part with the number, name the chapter 18 smart connector solid board part. Do the assembly, move the hardware part to the in context hole and make sure they go through the outside thickness of the dummy sheet metal part. Although it's generally best practice to avoid mating part of the context feature, in this example you're doing exactly that. Keeping in mind the best practice suggestion is more like a guideline. If you're having a performance problem with an assembly, this may not be the best technique. Use sometimes there's a price to pay for the sophisticated functionality. If you think your design can afford the price, will benefit with the functional, then you should use it. 7. I show the assembly smart component. Nothing ever in the place of the Make Smart component of the toolbar, assembly toolbar, the button is not there. You can have the assembly toolbar, choosing tools, customize menu, or choosing tools, Make Smart component. The resulting interface is shown in figure 1831. In the Smart Component selection box, select the connector part, Smart Connector, component section box, selecting 2 hardware components. This feature selection box, select the in-context feature of the dummy part. You are now finished setting up the Smart Component. Click the green check mark icon to accept the changes. Exit the property manager, save the file. Alright, 1831 shows smart component property manager interface. Alright, creating auto sizing smart component. Simple smart component take up to 20 minutes for the model setup. Not too bad a feature for the will be probably used often. The benefits are somewhat modest and treat the recomponents of feature. However, when it comes to auto sizing example, it should be shown next. The benefits are more of the extent of the whole size. 7 of the individual parts are played with it, including technical toolbox part, 3 of which are automatically sized depending on the geometry for the smart component. Is dropped with an in-context features added at the beginning. Open with a part of the website with the downloaded material. Chapter 18 clamp start solid part. Notice the multi-body part. You do not need any special knowledge of multiple body complete tasks. The multiple bodies are discussed later in detail. Chapter 31 multiple body parts. Modeling multi-bodies. Alright, with the clamp start part open, click through the configuration, examine the design table and part. You can see the various design changes. Note that several configurations already exist. Primary dimension, change the diameter of the hole, change the drive of the diameter distance between the mounting holes. No, you can only drive the auto-sizing cylindrical geometry part with the smart geometry component definition. Include the mate reference for the parts over the big hole automatically snaps. The cylindrical geometry and other aspect is the in context over the match mounting hole to the plate figure 1828. Show the assembly with this part meant to go with the clamp stamp to the hole stab to the shaft adds to the hole and plate. 2. Open the file chapter 18 all size training assembly solid assembly. This has been prepared to help you get started with the smart component training. Note the shaft is necessary for the training assembly. The training assembly is intended to create this in context smart feature to create the configuration table of the shaft that has been added with the visualization only. Enter the clamp part with the assembly and mate with the eccentric of the shaft with the coincident with the blue plate. But this does not matter where the clamp site is along the shaft, but it is fully made with the location does not make side back for distance made from the plane or plane interface would be a good choice. Edit the plate in the context assembly, convert any of the mounting hole of the clamp with the create the holes plate with the align with the holes and clamp. Exit edit component mode, activate tools box, set 4 holes in shown figure 1831, insert socket head, cap screws 3/8 inch, 3/8 by 24 by 5/8 inch. If you do not have the toolbar change to not use then you use the part with the correct name, correct size configuration, then provide the website downloaded material. Inserting 4 screws, you have to create a part, insert into the assembly configuration. Please select the 4 edges. Use the same fastener, place the mounting holes, use the correct side of the holes, use the cycle length, use the default 2 1/4 inches from the mounting holes. Alright, note, working with the length of the fastener, clearing operation smart component with the length of the dependent on the thickness of the plate, controlled smart fastener. Smart fastener can't afford except through the mates. Remember the auto side of the driving only with the diameter. Later in the chapter you will see how washers and nuts are put in place on the underside of the plate, but the screw length cannot be automatically calculated unless the actual screw head in context relation to the nut where it is not possible using toolbox. Place washer and nuts on screws backside of the plate. When the shaft diameter chamber, the hole in the clamp chamber, the match within the range of the plate will be established. As the clamp becomes larger and bigger screws are needed to secure the clamp, the holes grow further apart. Bigger screws mean additional configuration for screws, washer, and nut parts. Remember, the configuration do not necessarily exist. You should not count. You should not count on smart components working with a many of the toolbox create new configurations. An example, the toolbox part are pre-populated with all configurations needed for the range of sizes involved with the smart component. When you make your own smart components, you must do the same thing in the intended with the all size of the toolbox part. Difficulty there, the configuration include with the diameter size of the screws as well as the length of the unknown until you place it in part. For this step, you must make the configuration available to the screws are properly. Up to this step, you have the assemble part of this will be only where you're going to do automation process comes next. Figure 833 show the training assembly at the point shaft plate shown for wide frame because of the external smart component. And then click make smart component tool with assembly toolbar. Previous example of this was the point of marking make smart component command was used with no different activate smart component selection block pick of the compliant part. Figure 1834 show the filled smart component property manager component selection block 6 screws instant 2 washers 2 nuts. In this feature selection block, select the in context features associated with the smart component. Although in context feature that can affect the single part, only a single part of this does mean that you're limited to a single context feature. In most cases, only one feature is needed, but there's probably a situation where there would be useful. Also remember that in context that are limited to extrude revolve boss cuts, holes, wizard holes, and simple hole features. The configuration table is set. A simple table that enables you to select the component configuration to be the smart component configuration works very much like an assembly design table, but it's not spell based. Every cell must be explicitly rather than using technique mass population assembling property range configuration as you do with a real design table. Each table is a down list of available configuration for the component. We'll have 4 instance single component which may be set each instance that each of the component figure 1835 show the configuration table example. Click OK, you're done creating the auto-sizing smart component. Alright, making files and smart components might accept the string assembly with extruded button and burden with the file management smart component that may seem counterintuitive, but in fact the only file you need to worry about is the actual smart component. Although they explain very well the documentation help resellers demonstrate with the topic, generally recommend that you simply delete the training assemblies after you're done with it, because if you need it's not needed anymore. Turns out that all the information to recreate the training assembly is stored in the smart component. This includes the in-context feature, which is stored library feature location associated components as well as the configuration table. Figure 1836 shows the part of the feature manager for the smart component. As you can see with the in-context feature for the associated components, face references are also listed here. Figure 1836 feature manager smart components. Deleting training assembly does not cause any data to be lost. We'll delete an assembly in the following section. Alright, editing smart components, expanding the discussion whether to keep the training assembly file with a little of the strategy you could try, make the smart component going through the preceding steps, following the tutorial, creating one of your own. You just make a simple smart component with perhaps the associated component with the context feature to delete the training assembly. To find the assembly gone with a period with no way of the edit the setup of the smart component, right click with the smart feature folder, the feature manager of the smart component, select edited and define assembly. Show figure 1837 of the Solidworks, recreate a defining assembly from the data store of the smart component. This assembly is saved in the simple system temp folder. You have the smart component name underscore template TA solid assembly smart component name with the context feature of the save of the temporary directory. The library feature filing. You have the name of the dumping part pending underscore library feature file name. For example, the dummy library feature solid library feature part. Hit a definition button appear with the upper right hand graphic window of the shown on the right feature for the 1837. Then cover the closed document X. Click with the button the smart component property in the interface that appears that enable you to change the selection of associated components and context feature chain of the auto sizing setting, edit the configuration table. Alright, therefore, all the settings preserved with the training assembly exist on only as a phantom in the temporary directory, although it appears with the counterintuitive works. Tutorial working with smart components. Tutorial guides you through the process of creating smart components using only the auto sizing feature that enables you to manually create the part of the sample like the full box bar, but with the toolbox functionality. Follow these steps. One of the part of the website with the download material file name chapter 18. Tutorial start. solid part. This part originally came with a toolbox already contains a few configuration. Making a symbol that contains only this part. Make the part with the smart component tools. Make smart component turn on the option auto size. Select small diameter of the part concentric with the mate reference figure 1838 shows the selection. And then quick configuration, table of the button, file the table looks like the figure 1839. Some of the configurations are blank because of the rows with the minimum and maximum value for the auto size function already set. The rest is overlooked. Filling the configuration table. Goes to the configuration table, click the green checkmark icon, exit the feature with the shape of the assembly, exit the assembly in the part, save the folder design label. If you do not know where to do the design label, it's located, choose the tools option, file, location, design library, display the part with the design library panel with the task pane, open the part with the download materials file, name, chapter 18, tutorial plate, solid parts placed in the part with the new assembly, drag the tutorial start with the component with the design label and assembly with the move of the part, over the holes in the drag the part up to the down arrow and part chain to the side of the match for each of the hole. Figure 1840 show that all the holes that are populated with the matching smart component side that is driven to the configuration table that is placed for the part over the diameters. To edit the configuration table to open the smart component of the part is open the window with the right click with the smart feature folder. The select opening to define assembly. An assembly was created with the data stored in the part opens. Click edit definition button appear for the upper right hand corner graphics in the window. Reassign the minimum maximum value of the 3/16 of an inch to 1/4 inch. Configuration shortest length, for example, the chart shows 3/16 minus 32 times 3/4 of an inch. Configuration be assigned minimum of 1/100th of an inch to maximum of 199 thousandths of an inch. Move the 1/100th to 199 thousandths of an inch values up to cell 3 and 16. 3 divided by 1632, 1/4 inch configuration. Do something similar with the 1/4 by 20, 1/4 28 1 configuration. Edit the part chart. Now looks the following. Alright, tip, you may be the difficult expanding width of the column containing the configuration name, thereby the difficult and powerful to read the end of the long configuration name. However, the Excel can expand with the height of the rows which cause the configuration names to wrap, as shown in figure 1841. Alright, tutorial. Working with library feature tutorial guides through the process customizing a whole wizard holds you with a special library feature for the drawing. In the library, editing, placing in the part and follow these steps. Open the new part, create a rectangular base feature about 3 inches by 3 inches wide, 3 inches deep. Pre-select flat face, start the whole wizard. Create counterboard hole with a heavy X pole. 1/2 inch normal fit bind with 1/10 of 2/100 of an inch. Deep, locate the hole dimension from the two particular ends as shown in the figure 1842. Click the green checkmark accept icon twice to accept the whole setting. Turn on the setting, view the dimension, name of the double click with the counterboard hole feature for the feature manager, show the dimension, make the instant 3D unselected for the next step of the one dimension from the creative locate the center of the hole, rename the dimension for the dimension property, primary value pane, name of which have the meaning on the place dimension of the X direction, Y direction. Do this. Both dimensions, edit the second sketch for the whole, figure 1843, show what the sketch should look like before after editing. Reconfiguring the whole. Caution: don't delete the name dimension from the normal to revise whole wizard hole with Solidworks. Should check the mechanism and looks for the name of the display of the error. And if any of the name dimensions are not there, there's no use for dimension. It still be there. It still must be there, although it does not need to be the original. Either could rename another dimension with the same name, simple dimension link with the center. Otherwise, unused construction. It does not matter about the function of the dimensions, as long as the dimensions within the name and sketch. Tip: remember that to get with the diameter dimension for the shown figure 1843, instead of the radius dimension, that you must use the dimension with the tool, select with the center line with the construction line with the line, end point one end, then move the cursor to the other side of the center line, place the dimension in order the selection does not matter. The cursor crosses the center line of the dimension, display with the diameter instead of the radius. When you're finished editing the sketch, rename the dimension, edit sketch, and exit the sketch. Click the keyboard feature twice. Click it once. Feature for F2. Rename splash hole. Pre-select the same flat face the first full feature was placed on. Start the whole wizard again. Place the number 8 by 32 tapered hole. Except the field depth, the default, the specified center distance of 3/4 inch between items. Special hole, horizontal, vertical direction. Rename radial dimension, mounted radius. Use cylindrical face with a special hole to make a circular pattern with the name taped with the hole, creating a total of 4 instances on the taped hole with the making special feature hole with the red of the taped hole with the pattern in yellow. Split the feature manager with window in two by using the splitter bar at the top of the button at the top, chamber the lower panel with the configuration manager and rename default configuration size 1. You create a new configuration solid size 2. Double click special feature chain with the dimension name C bore. Diameter 1.5 inches by chain with the configuration only. Use the drop down menu. Make the dimension chain with the mount red at dimension 1 inch. The result of the steps are shown in figure 1844. 17 auto create a design table shown on the insert of the design table. Selecting the auto create option, edit the design table to look like figure 1845. Hide and delete extra columns as that match is shown. Tip, remember to fill the first two columns in size 5. You make up the 2x2 selection size 1 entry. First two columns pull up the down, hold the handle low right corner selection box. Appropriate box filled. Manually fill C board diameter value of the bolt. Put in cell D3. The type of the equation C3 3 C equal to C3 3 halves is plus a quarter. 25 hundredths of an inch for the same field equipment technique property. Populate cells D through do 7 to click outside of the design table to close the success configuration. Make sure that all the work the design library rather the folder you would like to put in the library feature. Make sure that not use the assembly sheet metaling forming tool. Click a face created with a special hole feature. Drag the feature for the lower panel of the design library. Add library property manager should appear on the left. Although you select the feature, dragging the library items to add the field blank, that may be selected with a special hole, tapered hole, circular pattern features, selecting multiple selections either through the detachable property manager, split feature manager, flyout feature manager, selecting feature of the graphic windows on the work won't work. Position zoom in the view of the part wouldn't save with a good preview on the library features. If you don't change the background color with the blue to white, this would be a good time to do so. 23, save the 2 plane, then make sure that you select the current folder and file with the name, and then click OK. Figure 8 from 46 show the completed property manager interface function. Tip, may notice that there are 2 library entries in the window. This becomes an additional path as added tools, option file location, design library. If the new library feature does not appear with the design library, then click with the design library, press F5. If you do not like the way it displays right, you can click in the blank space inside the lower library window. Select one of the 3 options. Edit the preview image of the feature. Right click with the feature of the design library window. Select the open reposition zoom. The view, click save with the click of the design library and press F5 again. From download mirrored materials, open the part with the chapter 18 tutorial blank solid part. If you'd like to examine the version small part whole, special whole part 1 created with solid chapter 8 special whole solid library feature. Notice the library feature part file, not regular Solidworks part file. Drag the special whole library feature from the design library onto the face of the blank part. Place the feature on the squared off the end of the select configuration on the list of the property manager. Although there is no prompt, the library feature interface hesitates the configuration library feature waiting for the user to select the configuration promptly. Actually does exist, but appears at the left hand or left hand core screen status bar with tiny font. Must you probably don't use it. So try to orientate the part in the same way that appears in the preview window as shown in figure 1847. 29 on the blank part, select the edges correspond with the preview window. Click OK, accept the placement of the feature. 30, double-click special hole feature change the X and Y placement of the dimension. Place 1 inch for the edge of the both direction. Place another library feature blank part on the selected configuration. Click the green check mark icon. Select the edges for the reference. 32, know that the feature manager appear with an exclamation mark. You will investigate with the color that you will see with the 2 dimensions. You should be attached to the edge of the dealing because you didn't select the reference for the placing of the library feature that was done with the purpose of a different technique. 33, expanding the library feature special feature for the edit. This first sketch of the hole, special hole. Displacement sketch, delete the 2 dimension of the axis for the dangling colors. Head concentric sketch, relation between the place points and the arc edge of the blank part. Edit sketch, error message should now be gone. The hole should now be placed in the center of the arc. Right click and second library feature to dissolve the library feature figure 1848 show finish part feature manager. Great job. Good job. Note, when you dissolve the library feature, you lose any of the configuration technique. May also be used for the reorder some of the individual features in the library feature. Bottom line, assembly features can be quirky if they are often used, especially if the niche applications have the functionality available, giving you another tool in the toolbox for solving the design documentation problems. Hole Wizard can be used in place of the machine holds multiple parts and automation greater thing. Should we all utilize it when it's helpful in your process. Master most basic step of reusing data. Form libraries, establishing location libraries using setting tools option and file location to do this. Determine if you need a local on your computer network location of the library. Master it. Make sure you know where your interface is. Design library, and how to navigate various elements. Toolbox can be an integral part using libraries from Solidworks learning to manage toolbox. However, the may drive the decision to create and manage your own library standard parts. Make sure they learn where weakness of the toolbox and how to work around these weaknesses. Chapter 19: Controlling assembly configuration and display states.